Okay, 2 more topics to this chapter. And I'm going to hopefully cover them in 10 minutes because I'm eager to get to the next one. We've been on 5 for too long. Using the C string member of strings. There are times when a string will not work. What do I mean by that? And this is just a tuck away into your head. I'm not going to ask about it on any exam. But if you have, where's a notepad? You know, the system command thing, right, like that. System requires what's known as a character array and not a string. So if I did this, string s equals, sorry, pause, right? We've been using pause. So if I did this, string s is equal to pause, and then I tried to pass that string in, well, system is like an old archaic command, and it doesn't know what a string is. So that would be an error. Instead, we have to say, please extract the character array, the C string. Remember, C++ is built on top of C. And so that gets the character array out of the string so you can use it. Maybe we'll make an example of that, maybe not. Breaking and continuing a loop. The continue statement and the break statement. I think we've already mentioned these, but we're going to mention them again because they're in the PowerPoint. You can use break to bail out of a loop early. Use sparingly, if at all. Now, you've seen me in class, we've been using while true occasionally. And if you have while true, there better be a break or else it's an infinite loop. The way it works is it'll bail out of the loop. And if you have an inner loop, it terminates that loop only and then repeats the outer loop once. So if you have something like this, right, for x equals 2, keep going while x is less than or equal to 10, x plus plus, but then for some dumb reason, we don't like the number 7. If x is equal to 7, break, else print out x. What's that going to print out? Well, x is starting at 2, right? So it's going to print a 2. Then it's going to print a 3. X is still not equal to 7, so no special behavior. 4, 5, 6.
8.
Now x is 7. You'd be right if that was the word continue. We'll demonstrate continue as well. X is 6. It prints it out. It comes back here. It adds 1 to it. X is 7. We hit the if statement. We break. We're done. So it would print 2, 3, 4, 5, 6, done. There's also the continue statement. What break does is it tells us to go to the closing brace. It bails out of the loop early. Doesn't matter what this condition is. And break works on do loops, while loops, and for loops. Just works the same way. And we've been using while true, like to ask the user for some data, and if they enter a special sentinel value, we kick them out of the loop. Well, that's what break was for. You know, if x was equal to -1, then it bailed out of the loop. So break causes the loop to terminate early and then run the code following the closing brace of the loop. So when it saw this break, it left the loop early and it printed done. Now continue is similar, except it causes it to immediately go back to the top of the loop. So if we copied this code, just going to copy and paste it, and I hope y'all are following along even though I'm not making you type code. If we change this to continue, it's going to do exactly what you said. It's going to start printing at 2, 3, 4, 5, 6. Now we're at the special value. X is equal to 7. So if that's true, it immediately jumps back up here. And so we never get to that statement, so it never prints out x. Instead, 1 gets added onto x, and we keep going, right? 8, 9, 10, and then done. So break and continue are similar. Break causes it to go to the bottom brace and continue, right? Or I'm not going to use the word continue in that statement. Break causes it to go to the bottom brace and continue, I did it again, and execute from there. Whereas continue causes it to go back to the top brace and execute from there after having incremented it. And we'll use while true. We'll keep probably using while true into the end of the semester. I don't use continue that much. All right, so breaking out of a loop terminates the execution of the loop. Their warning is used sparingly, if at all. It makes the card holder? Isn't that a character in Game of Thrones? Makes the code harder to understand and debug. That's a matter of opinion, though. I think if it's well used, like in a while true loop, and if there's only one break statement in it, it's okay. And then continue. Continue goes to the end of the loop and then prepares for the next repetition. And they all work the same way. Again, use sparingly. It can make the program logic hard to follow. All right, that is the end of this chapter.
Now it's time to go to chapter 6.
Yeah.
I think I'm taking Java, but the only class in the spring is online. It's with some guy named David Swingle.
He's a good teacher. And if you get stuck, you could always watch my videos because I've just recorded a semester's worth of Java videos. Or you can come by and ask me for help. I've had people come by even if they're not enrolled in any of my classes and say, I'm taking somebody else's class, but I'd like some help. It's okay by me. We're all working for the same goal, your education.
And we're all going to be next game designers, okay?
Alrighty, functions. This is one of those chapters where we've been doing it all along, so we know what a function is. A function is just a block of code with a name. So it's part of modular programming. Modular programming, the idea behind it is you break a program up into smaller steps, smaller parts, to make it easier to understand. So you could write a program where the main method has 500 lines of code. Let's not get too extreme. 500 lines of code in the main method. But if you think about it logically and figure out how to do it, you might be able to break it up so that you have 5 functions of 100 lines each, and the main is only 5 lines long, and it's calling function 1, 2, 3, 4, and 5. So function is a collection of statements, a body of code between 2 curly braces that perform a task, or it's a named block of code. So it's supposed to improve the maintainability of programs. What does that mean? Well, you know, after somebody writes a program, somebody's got to keep fixing the bugs in it, or add new features to it. Might be you, might be somebody else in your team. You might quit the job and some poor other person has to do it. Well, with maintenance, you got to figure out how the program works in order to carefully fix what's broken. And if the code is logically broken up into functions, like there's a function called open file, and then there's a function that's called make report, and another function called save to database, something like that, then when you're fixing it, you know right where to go in the code. Oh, I'm going to be modifying the report. Well, I'll go to the make report function. Or, ooh, we need to support another database format. I'm going to go to the save to database function. So, improves the maintainability of the programs. Simplifies the process of writing programs. Well, what does that mean? Well, if you wind up writing code that seems repetitive, you've copied and pasted something, and then you've copied and pasted again. By about this time you've pasted it a second time, think to yourself, oh, that should have been a function. Because you may wind up pasting that a third time, and a fourth time, and a fifth time. Well, what's the problem with that? Well, if there was a bug in the first time you copied it, that bug is in every example of it. Or what if you go in and modify the third copy of it that you made, but you don't remember to go and change 1, 2, 4, and 5, right? So, if you ever have a block of code that needs to be in your code more than once because you're copying and pasting it, instead put it into a function.
So basically we want to create multiple classes for each of these, right?
Well, we're not doing classes, but just like the methods that you've been learning in your classes, that's what a function is, right? Except it's not attached to a class. So defining and calling a function. Well, in Python, you did it with the DEF keyword, right? DEF, my function, like that, right? That's how you did it in that language. Well, you don't do it like that in this language. Instead, you have to give it a return type. Int, maybe, although it's supposed to be lowercase. Thank you, PowerPoint, for continuing to... There. And then you give it a function name, right? And you don't put colons in this language. Instead, you put the blocks, right? And so inside Python, whenever you wanted to call myfunct down here in main or whatever, you would call it, you know, myfunct, like that. Well, except you wouldn't put a semicolon if it was Python. You do since it's C++. So we can go in and define functions. A function has to have a return type, a name, a parameter list, although it can be empty, right? Just nothing between the parentheses, and then a body. So your function definition has to have a return type. Int, void, meaning it doesn't return anything, double, string, whatever it's going to return. And then it has to have the name of the function. Same rules as variables. It can't start with a number and it can't have spaces in it. And then a parameter list between the parentheses. It could be an empty parameter list, meaning that when you call it, you don't send anything to it between parentheses, or it could have a whole bunch of them. And then lastly is the body, the statements that perform the function task. Let's do that. Let's go and make our new lecture. Lecture Tango, Lecture T. So I'm going to make a C++ app. Please do not choose console application. Instead choose empty project. Let's call it Lecture T.
Oops, I will fix that later. Nah, don't worry about it.
All right, now that I have my project, I'm going to right click on source files and give myself a new item, and I'm going to call it lecturet.cpp.
I'm going to get rid of this cout lesson hello.
Yep, we don't really need that. I need my boilerplate, so I'm going to run back over to our code, and our page, and click Modules Boilerplate Improved. It's way up here on the class information, so boilerplate improved. And I know we already know this, but there we go. I'm going to copy all that and paste it. The last lecture of the day is always fun because my voice is starting to give out. All right. Let's write some functions.
Hey, let's go.
Void F1, simplest function, is just going to print hello. Cout less, what, I can just copy and paste that line, right? But anyway, cout less than, quote, hello from F1, \n, end quote, semicolon. Now we're going to write another function that calls F1. Void F2, parentheses, end parentheses, open brace. F1, well, let's make it say hello as well. Cout less than, quote, howdy from F2, \n, end quote, semicolon. And then call F1, parentheses, end parentheses, and F2, parentheses, end parentheses. And now down in main, I'm going to delete that cout hello, but I'm going to call F2 parentheses. And so what's it going to print? I'm going to call F2. It's going to jump up to here. What's the first thing it prints? There's 4 of y'all in there. Somebody can read it out.
The howdy.
Yeah, so it's going to print howdy. It jumps from here, prints howdy, and then it hits that. Oh, by the way, that was a mistake. That's going to be an infinite loop kind of thing. I need to change that F2 to F1.
Yeah, because you're inserting the function inside the function.
Yeah, exactly. Okay. So make sure you fix that.
I mean, when that's how it.
I mean, unless you want to break the code.
Yeah.
It'll cause a crash. So anyways, it prints out howdy, and then it calls F1, which prints hello, which returns, and then it calls F1 again and prints hello again. So we're going to see howdy and then hello, hello.
Why do you have F1 twice inside the F2
Just to
function?
prove that it's going to call it twice. Let's take it out.
And oh, we gotta have a void.
Yep. We're going to avoid return types. That's a joke. All right. So it says howdy from F2, hello from F1. And as Parker noticed, we had F1 in there twice. So now when it runs, it's going to say howdy from F2, hello from F1, hello from F1. And if we come down here and we call F2 twice, we're going to see the same sequence of messages again. Howdy from F2, hello, hello, and then it's going to come back. It's going to come back up here, howdy from F2, hello, hello, and then it's going to come back. And that's, in fact, what we are seeing. Just to make it a little bit easier to see, I'm going to put a star in front of that. I don't know why. I just feels like easier to read to me. Okay, so a void function is one that doesn't return anything. We don't have a return statement. What if we want to return something, right? Then you got to give it a different return type than void. Why can't you? You can. It's just that you can't return a value. That works fine. But if I wanted to return 0,
Oh yeah, because the function you have to define it at
Yep.
define the function.
this has to match that,
Okay.
right? So it'd have to be an int or a double or something that can be a 0.
You gotta give a value to the function.
Yeah. Whoops. Like a function that returns a square of something. We pass in a 3, it's going to return 9. Yeah, we could just call math.pow or something like that, but so we're going to write a function that returns a double so that we can say, I want the square of 7.5, and it'll return whatever that is. I don't know off the top of my head. So I'm going to call it square. And it's going to take a number as input. So it needs a parameter variable. It's also going to be a double. I'm just going to call it x, whatever. Variable names only matter to humans as long as you use it consistently. You know, I could call this Gilligan right there, and as long as I use the word Gilligan everywhere else I'm supposed to, it would work. So, double space result equals x times x. Or we could use math.pow if you felt, but this, I think that's good enough. And then return result.
And then we make the call to that function.
Yep, we're going to come down here inside main, and I'm going to see out less than the square of 7.5 less than ENDL. And apparently the square of 7.5 is 56.25.
Well, why don't you just call it double square area?
I don't know. I'm going to leave it that way.
Well, because
And if I wanted to call it cube, I would make another one right. Yeah, go ahead and write one called cube that multiplies x times x times x. Just write your own function called cube. I'll start it off. Double cube, and then you finish it.
Can you scroll down 1 second?
Yeah, why don't I do that? Because you can't see how I called it.
Yeah.
There we go.
You're good.
Is we're going to move these functions into another file. Well, that's crazy talk. Why would you do that? Because once your project is thousands upon thousands of lines long, you really need to break it up into separate files. Now, you don't need to do that for the homework unless I ask you to. But what we're going to do is we're going to take these functions. Tell you what, copy everything. From there all the way down to there. Everything except for main. Just starting from the top. I'm holding the shift key and the down arrow. and I'm getting everything except main. Then I'm going to right click and choose copy. And I'm going to create a new source file. So I'm going to right click on source file and do add new item. It's a C++ file, but I'm going to call it functions. Functions. And then I'm just going to paste. All right, since I copied and pasted, I have multiple functions with the same name in multiple files. So that's actually going to be an error. It says one or more multiply defined symbols found. What does that mean? It's because F1, F2, and square are defined both in our new file, and they're still in our old file. So go back to your old file and delete F1. After you put it in a new one, right? And F2 and square. All right, well now we have errors all over the place. It doesn't know what square is. It doesn't know what F2 is. That's what prototypes are for. That's what header files are for. What is a prototype? A prototype is a function without a body. It just ends in a semicolon. Kind of like what you just did over there with your semicolon. So we had several functions. We had one called F1, looked like that. We had one called F2, looked like that. And then we had one called square. Square returned a double. And what type was its parameter? What did it accept? If you went back and looked at functions.cpp, what was inside the parentheses for square?
A double.
Yep, a double. Close parentheses, semicolon. Now the code will compile again. It'll run again. There we go. This is okay, but really we should create a header file that has these prototypes in it. So what are we going to do next? We're going to create a header file that has these 3 lines of code in it. So copy them. Select those 3 lines, your prototypes, copy them, go to header files, right click and add, and this time we're not going to do a CPP like every other time. We're choosing header file. And let's name it the same thing as our CPP, which was functions, right? I think we call it functions. Yes. Functions.h. And paste those 3 prototypes. Now there's a special little thing we're supposed to put up at the top of header files. Even if the book doesn't explain it, I'm going to use it right here. It's a weird word, pragma. P-R-A-G-M-A. Pragma once. What that means is that if this header file accidentally gets included more than one time in a file, only include it the first time. You kind of just blow off the meaning of it. Just remember to stick it at the top of every header file and you'll be good. So every time I create a header file from now on in this class, I'm going to be putting that up there as a matter of course. Yes, sir?
So pragma once basically stops functions from repeating?
Stops it from being included more than once. If I went into Lecture T.cpp, we don't even have the header file yet, and so I don't know how any of this worked. Oh, because we haven't finished our process. Let's finish the process and then we'll get back to it. So we moved our prototypes to their own file, so now it's broken again. Well, I said it's broken. Rebuild. Oh, I have not deleted these prototypes. I moved them into functions.h, but I have not deleted them from the CPP. So delete those 3 guys from the CPP. Our code is almost perfect, but it's not going to compile anymore. Same problem. It doesn't know what square is in F2 because it doesn't know where the prototypes are. So we're going to add a # include to bring our header file in. # include. When you're including your own header files, you use quotes. Functions.h. So what does that # include really do? When it's compiling, it runs over to this header file. It copies all of this stuff and pastes it right there, effectively, right? I mean, it doesn't really do it, but that's what it means.
I love this. So I can actually start making all my functions all into different header files.
Exactly, right.
And this saves me a lot of space in my code.
And so the reason you do that pragma once is let me make a change that would break the code. Don't follow along with this at this point, but I'm going to move F1 into the header file. No, I'm going to move square into the header file. You should not do this. You should not define your functions right inside a header file. But it'll probably work.
But it might screw up the code.
But without that pragma once, it's not going to work. So when I run it, everything's cool and all that. But if I had, like I said, don't make that change. If I had this includes in here twice, it's going to be okay. But if I delete that pragma once, it's no longer going to be okay. The reason why it's not going to be okay is because it brought this code in twice, right? And so when it brings that code in twice, paste, paste, we have two copies of the same function being defined. So you say to yourself, but I'd never do that. I'd never add two includes there. Yeah, but you might have another header file that needs functions.h, and so you might have a header file that includes another header file, and you can eventually wind up with a circumstance where one header file is including another one, and so it's actually winding up being included more than once. So let me undo all these changes now. What did I do? I remember moving square out of the CPP, so I better go and get that and cut it and undo it. And then I'm going to walk around and make sure that y'all are all okay. Once it works for me. Whoops, nope, I didn't get it right yet. Two errors. Syntax, missing semicolon. I wonder where...
You have to put pragma once.
Yeah, I took that out, didn't I? But is that the only problem? Oh, I accidentally, for some reason, have an X there. All right, and then pragma once. All right, so this is the contents of functions.h from there to there. It's just got our prototypes. Prototypes are function definitions without a body. What are they used for? To tell the compiler what kind of parameters the function needs and what kind of data it will return. So prototypes tell the compiler what kind of parameters, right, the thing between the parentheses, the function needs and what type of data it returns. Without the prototype, the compiler doesn't know that square accepts one double and returns a double. And the compiler wouldn't know that F2 doesn't take any data in here and that it doesn't return any data. Once something is defined with a prototype, you kind of have to follow the rules. We made F1 where it doesn't accept any parameters, right? So if I went into my main and I tried to pass in something there, it's not going to let me. It's going to call that an error because the prototype is telling it, nope, you can't have any arguments. F2 was supposed to only have 0 arguments. So function does not take 1 argument. Too many arguments in the function call. The prototype told me that, or told the code that. If I want a function in there, I'd better add it there. Like there. Square does accept a value. And if I goof that up, if I make square not have any function, not any parameters, if we don't pass any arguments to it, again, it's a syntax error. Because the prototype says, yo buddy, you better be giving me a double. But I'm not. So that's another error. And if you wrote a cube function, move your cube function into functions.cpp and move a prototype for it into functions.h. If you didn't do the cube function, blow it off.
Blow it off.
So here's what functions.h looks like. Here's what functions.cpp does. The last thing we should do to make our code all perfect is that functions.cpp, I think I said p too many times, should also include this header file to make sure that they match these functions exactly. So # include, double quote, functions.h. That's what header files are for. One of the things you use header files for is to hold prototypes for the functions that you have put in other CPP files. You could have a project, and this is not unrealistic, with 20 or 30 different CPP files. You can be sure that Excel or Word or whatever are probably consisting of hundreds upon hundreds of CPP files because they are huge programs, right? Extremely complex. They break them up like that, and then they put the prototypes for them in header files. And they try to break them up logically, right? All the graphical user interface is going to be done in these CPP files. And all the file I/O is going to be done in these CPP files. And all of our math functions are going to be in another one. So they try to break it up. Okay, so that's what header files are for, or one of the things that header files are for. The other things you can do inside header files are, like if you have any macros defined, like do you remember maybe once or twice we did something like this? We defined, I don't know, max score equal to 100 or something like that. I know we've done that before. You can put those into the header files as well. We don't have any reason for that in our current example, so I'm going to leave it alone. All right. Main is a function, so it has a return type. Its return type is int, so we have to return something. We return a 0. Why does main have a return type? So that if you're doing system administration and you write a script that calls main, you can check what it returned to decide whether your program ran successfully or not, right? So your system program, you have a Linux bash script, it calls main and then it checks the return value, and maybe 0 means it works correctly and -1 means something happened and -2 means something else. So if a function does return a value, the type of it has to be written there, and if that's the case, it has to be something compatible with that, right? Since this is defined as an int, it has to be something that can be turned into an int. So I would not return a string from here because a string cannot be converted into an int. Better be a number, preferably an int, right? Java is a lot pickier about what can be returned. If you define something as an int, you better not even try to return a double or a long or anything like that. C++ will go ahead and do it and give you some warnings in the compiler. Or if it's not going to return anything, there's no return statements in it, you just call it void. In Fundamentals of Programming, if it has a return type, y'all call that a fruitful function. A fruitful function is something that returns something. And then if it did not return anything, it was called a void function. Now the only thing is that in Python you did not have return types. You just wrote it like that with a def keyword. But the textbook still called them fruitful functions or void functions, even though you didn't have the word void. So when you call a function, you have to give its name. You have to use a parentheses. Of course, you have to have the semicolon, and between the parentheses, if there are any parameters, you put arguments to call them, just like when we called square. When we invoked the square function, the terms call and invoke mean the same thing. This is a function call. It's invoking the square function. That's the argument. That argument fills in this parameter variable right there. Now, variable names are just for our own benefit, so we could have called this anything we wanted to. I don't see a rename option here. So I could have called this, you know, Susie. And it would work as long as everywhere, right? Don't make this change, right? It still works, right? And then, you know, Barney. Barney the dinosaur. There we go, right? Still works, right? The variable names are just for us, but try to pick good variable names. Susie and Barney are not good variable names. I think I'm going to undo that. But it would work. The code would run just fine. So when called, the function executes the body of the called function. And you've seen me switch on the debugger, or maybe you've used the breakpoints as well. If I set a breakpoint here in main, by coming out here and clicking on the margin, and then I click the debugger, it runs it to that point and stops. Right? It's highlighting that line, and it's stopped there. These symbols, step into or step over. Step into means go into the function call. Well, we have a function call right here. So if I do step into, it's going to wind up being inside the square function. So I'm going to choose step into. Boom, now I'm inside the square function. And x is set to 7.5 because that's the argument. So that argument got copied into x. Now there's nothing to step into at this point. So if I chose step into, I don't think it'd do anything. It'll do the same thing as step over. What step over does is it executes that line. And even if it's a function call, it doesn't zip into it, it just runs over it. Okay? So inside the debugger, if we scroll up here, we should see a window that's got all of our variables in it. I have a variable called x that was defined here, and a variable called result that was defined here. Now result doesn't have any data in it yet, but it's gonna as soon as I step over this line, right? Because it's gonna calculate what x times x is and store it in result. So step over, result has been calculated, it equals 56.25. It's ready to be returned. So I'm going to step over again, or you can choose step out. They do the same thing at this point. Step out returns from the function. So I'm going to step over, and now I'm back outside, right? I'm back into main. And so if I click step over again, it finishes doing all that, and the cout has actually printed something, right? Same business here. Whoops, I did not mean to click the close X. Is it going to crash on me? All right, so now I'm here. When I click step into, all right, let's click step over, right? So I'm going to do step over, and it's not going to jump into F2. It's going to just go to the next line. And I think it actually closed the program because I clicked the X. So I'm going to run it again, but I'm going to set the breakpoint to here this time. So it runs it there. I'm going to step over that line, right? So it's going to go from there to there. And now that it did that, it printed out all that howdy from F2 business. I'm going to click step into. And so it's going to actually enter that function. Now I'm inside the F2 function. I can step over, and I'm going to go step into the F1 function. Comes there. And so I'm going to step over, it hit the return statement, so it comes back here. And now it's ready to call the F1 function again. Step into, step over, return back to where we were. And now we're inside F2, return back to where we were, and we're back in main. You could teach weeks of debugging. It's really important. I hope y'all start debugging your programs when they don't work, because if you go to a professional environment and the programs are a lot more complicated than our 20 and 30 line programs, there's no way you're going to be able to figure out what they're doing without loading up the debugger and figuring it out. So main can call as many functions as it wants, and then another function can call as many functions as it wants. But the compiler has to know about the function. That's what our prototypes are for. That's what our header file is for. The compiler has to know the name, what the function returns, the number of parameters, and the data type of each parameter. So you put the prototypes before where it is called. It wouldn't do any good if I had put my prototypes, right? If I went here and I did that # include and moved it to the bottom of the code, that'd be dumb. It would no longer compile. How do I keep getting that X to show up there? I guess when I cut and paste. All right, so why does that not work? If I build it, it should not compile. Okay, it's showing 3 errors. F2 not found. Square not found. So what's wrong? Why is F2 not found? We have our # include. We're bringing in our prototypes. But are the prototypes being brought in a place where they're useful? Prototypes have to be defined before the function is called. So having the prototypes defined down here doesn't do a lick of good. So that's typically why you put all your # includes up at the top. There's no law that says # includes only can be at the top. They can be anywhere inside your code. But they need to, the prototypes have to be defined below the function call. So here they have some functions called first and second, and we see the prototypes. We don't even see the bodies defined anywhere. Now, if you define prototypes without defining the bodies, you're going to get an error. I'll show you what I mean. What if I wrote a function? I'm going to go to the header file, and y'all wrote a cube function, or at least some of you did, right? That's its prototype. I could go over to main and call the cube function, right? I'm just going to copy that line. You don't need to be making these changes. It's all right if you didn't do the cube function. I'm just going to demonstrate how it breaks. Okay? So it's going to compile just fine. If I do project build solution, there's not any syntax errors. But the linker says one unresolved external. What it's telling me is that cube has a prototype defined but no function. Nowhere in our code is the cube function actually defined, right? Because all I did is I created the prototype, but I never put it in there. If I go to functions.cpp, I don't have a cube function. So when it tries to build it, everything compiled fine because we had a prototype, but we didn't actually have the function itself, and so we get a linker error. That's what unresolved external means, is that the function was defined somewhere, the prototype was defined, but the function itself was not. So if I want cube to work, right, I'd actually have to write it. You can't just create a prototype without having the function around. Doubled result equals x times x times x, return result. Now it'll build and compile and run. If you ever see unresolved external, it means that a function has been left out, or it's got the wrong type or something. What if I did this, int y? I thought I was going to cube something else. I don't see any syntax errors. It's not underlining anything as being a syntax error. But when I build it, it's going to be back to telling me unresolved external. The reason why is because this thing needs a version of cube that accepts one argument. And even though there's a header for a cube function that accepts one argument, there's no body for a cube function that accepts one argument. The only one we have is this one that accepts 2. So I'm going to fix that.
I'm ready to joke program.
Prototype notes. You try to put your prototypes near the top of the program or in a header file. And the program has to have either the whole function, which is why we've been sticking functions up above main, or at least the prototype before the call to the function. Otherwise, it's a compiler error. And when you use prototypes, you can put functions in any order in the source file. Right? I could put the square function above main, below main, and another CPP. Sending data to a function, that's what the parameters are for. We sent some data to our square function. This is called a parameter variable. When we call it, this is called the argument. The argument fills in the parameter variable. And the types have to match or at least be something that can convert from one into the other. Square is expecting a double. But if I pass in an int, no problem, because an int converts to a double just fine, right? There's no reason you can't. However, if I pass in something incompatible, like a string, that's a syntax error. That's why it's underlined. So you can pass values into a function when you call it, like POW, the math function. Here we are passing in two values, A and B. I'm assuming that they're numbers, right? Values passed to functions are called arguments. And the variables in the function that gets those values are parameters. So here they've written a function called display value that accepts a parameter and stores it in a parameter variable called num. And then it prints it out. So they have a function prototype up at the top. The prototype is just the whole function, except you don't have to put the variable names there. You're allowed to just leave int there. Now, I think variable names are useful, and you can leave them in your prototypes. When I demonstrated it here, I took the parameter variables out of the prototypes, right? When I was here looking at the prototypes, that's all the compiler needs, is to know what kind of data can be passed to it. It didn't need to know the name of the variable, of the parameter variable. But it doesn't cause a compilation error if you leave the variable names in there. Works either way. I actually like leaving the parameter variables in there, but strictly speaking, they're not necessary, and so this is what the book is going to show. So it has a function prototype, and main is calling it. And somewhere there'd better actually be a definition of that function, or else it's an unresolved external error. So underneath main, they wrote display value. They actually have the body of the code. This is just noting that the parameter can be called a formal parameter or a formal argument, whereas the argument can be called an actual parameter or an actual argument. Well, why muddy the water? This is the parameter. That's the argument. Let's just leave it at that. So when you're defining your functions, you have to give it a data type and then a name. That defines a parameter variable. So the value of the argument is copied into the parameter when the function is called. Right? When I call that square function or that cube function, why can't I find Visual Studio? There it is. When I call those functions, this gets copied into X over here. That's called pass by copy. Some languages like Python and Java, that's all they do is pass by copy or pass by value. However, this language also supports passing by pointer and passing by reference, which those languages don't do. So when you're calling a function and passing multiple arguments, the number of arguments has to match the prototype. And you saw me demonstrate that, right? When I modified square to expect two values, but the calling code was only giving one argument, it was a compilation error. All right. Let's crank out some homework. I think it's going to be pretty easy. Write some functions that meet these specs. Function name is, I don't know, count. It returns void. It has, its parameters are none. And what does it do? Use a for loop to count from 1 to 10. That's what the count function is supposed to do. Let's write another function. The function name is going to be add. Its parameters are int x and int y. It returns an int. That's its return type. And what does it do? What is its purpose? It adds x and y and returns it. Returns for purpose. Returns the value of x plus y. Have main, your main method. Ask for x and y. Call the add function, storing and display the results.
Thank you for showing
Also,
header files.
Also, have it call your count function. You don't need to use header files. If you feel like it, great. You don't need to put these functions into a separate CPP file. If you want to, fine. But do put the count and add function below main and put prototypes of them above main. And if you get stuck on that, text me and I'll be happy to give you hints. And that's kind of a but if you don't. That makes sense, gang? Strong thumbs up? Medium? Yeah, alrighty. Parker's the only one not meeting my eyes. No, I'm just teasing Parker. Alright. Okay. Let's make a Dropbox and be done for today. Except I'm going to put this straight into our...
I made a little surprise in my lecture program. Hey Parker, guess what I just created